Hey guys, and welcome back to class. So for those of you who are out sick right now, you need to actually have out one of my favorite things. If you don't have it, I have you hooked up with a PDF file. But if you have this book right here at home, this is what you need to do, and this is what you need to be on. You need to be on pages 143 through 152. So I've actually ripped those pages out of that book. But this is what I have for you guys, but I have it so I can send it to you via email. So I'm going to put me down here because, you know, we can. So it's under a textbook PDF. It pops up. It's here. Everything's online. I've showed you guys before how to go into Canvas and to pull this up. In class, if I have not done that with you, all you're going to want to do is you're going to want to click into here, go into your county website. You're going to go to your V portal, and you're going to click and do all the launchy thingies. Click to sign in the password. It's going to ask me a whole bunch of weird questions. So it's a waiting game. Hold on. Why is it not popping up? Okay, we're having technical difficulties. Grand. Alright, so you just want to go into Canvas. And for me, I have more than one. So it's under this 8th grade resource. It should also be under these resources as well. I have not yet checked, but I know for sure it's under this one. So you want to... It's right here. Access your textbook resource online by clicking here. So I'm going to click there. And it's just by what we do. So if you know your next DIA is going to be on the universe, right here, DIA 5 is on the universe, and you kind of already know, it says the sun and our stars, you're going to click into it, and you're going to find the lesson that I tell you to find. So here's the ebook, and it says the sun, so I'm looking for the sun. All right, awesome. So click that open, or the student PDF. All of these are here for you. So this is for you. So I'm going to click open the PDF version, which is going to give me this, which I have right there. See, there it is. And it's right here on Canvas for you guys. And I made sure that everything is all good and groovy for you guys. As you see, I don't think you can do anything on this part. That's why I downloaded it. I saved it for you guys, so that way there you can do all the fun things to it. But if you want to just read through this right here on your own, I'm going to read it with you, of course, like I always do. The really cool thing is you have this read aloud. So if you're here and you're having difficulty, say you're doing something and you're super busy and you don't have time and you just want to put it in your pocket because it's in your cell phone, because you know sometimes you have YouTube up. YouTube, once you click that screen button off, it goes away, the material stops, but here it won't. So let's click it. Okay, we're gonna pause. That was awesome. That guy's voice. So this is voice options, so you can go around and say normal voice. Can we change his voice? His name is David. Oh, let's do this one. All right. So because you know we have to be cool because this is science. What? I don't know what to do with this. All right, hold on. Okay, we're gonna stop doing that for a while because that's gonna get on my nerves. I don't know about y'all, but that's kind of cringy. However, if you guys do need someone to read it to you, there's definitely someone that can read it to you. There's 3 someones, in fact. No, be quiet. Voice options. So you could actually speed it up and make them speak faster, make them speak slower if you need to. I don't mean to laugh. I picked this random lady's voice. So you have 3. You have David, Mark, and Zira who can read to you. One is, it says United States English. I don't know what kind of United States English that is. Sure, we'll go with it. But however, if you want to listen to me ramble on, teach you, or them, that's up to you. So there's that option there. So it's just the read aloud, and you can listen to it in your pocket like an audio book that's really poorly written from the 1970s. So you can listen to that, or you can listen to me read to you. Lesson 3, the sun. The essential questions are, what are the properties of the sun? By the end of this lesson, you should be able to describe the structure and rotation of the sun, energy production and energy transport in the sun, and solar activity on the sun. Ooh, look how pretty. These are pictures of the sun. Different types of activity occur on the sun's surface. This loop of gas that extends outward from the sun's surface is a promance. So there we go. Isn't that cool? It's just sort of like, think of volcanoes. And I don't need to read all of that to you. You're not going to pay attention if I read you the standards. You're going to be like, what does that even mean? I'm just going to teach you the standards because it's way more awesome. I mean, unless you want to go back to listen to robot voice. All right, so your lesson quick labs, really quick. So we're making a solar system. All right, no, we're not. Just joking. Haha. We already have one in class because we already made one. Create a model of the sun. Hey, guess what? Somebody already did that too. We're a step ahead. All right, so engage your brain. Number 1, predict. Check a T or an F for true or false. All right? To show, rather, you think. So this is a you think type of thing. So you're going to go through here. If you're at home doing this, go through here. Tell me true or false. You will not be counted as horribly wrong if you get these horribly wrong. It's going to be okay because what is it? The beginning of a lesson. And do I ever fault you guys for not knowing something at the beginning of the lesson? Absolutely no, I don't. So over here, explain in your own words. So explain the meaning of the word sunlight. What do you think the meaning of sunlight is? Again, right here. Explain in your words, not definition. What do you think sunlight is? Okay, I do not want to see a term from a textbook. I want to see little humans writing little human thoughts in this little human box. Okay, great. Reading activities. You can often define an unknown word using the box below. I love these little boxes. So word part is photo, light, which is meaning, it says photo, light, sphere, ball. So photosphere means light ball. That's what that means. So we broke it down. So photosphere, what is a photosphere? When we break it down, it means light ball. Not light bulb, like you put in the kitchen ceiling. No, light ball. Think of a big bouncy ball with a light inside of it. So here are your new vocab terms. You have solar flares, sunspots, nuclear fusion, which I know a bunch of you know about already. And our new fancy word that, your teacher is not going to be able to say because of her speech impediment. However, I will give you 2 points if you come and you tell me what that word means. Or actually pronounce it correctly for me. That'd be great. Apply a list that contains the key terms you'll need in this section as you read. So you know how we are. We like to mark it up. So you guys already know that I have my favorite fancy green pen. I can't draw on this thing. I don't like not drawing on things. However, I guess I'm going to have to deal with it. Because my highlighter tool is not working. Well, I know there's some of you who are like, just take your PDF and transfer it into this way and then you can do the things. I don't know how to do all the fancy things. I'm not a fancy person. I'm a papery type of person. Anyway, so example sentences. Energy is transferred to the sun's photosphere by converting cells. What is this? What is this? So use the word photosphere in a sentence on your own. So what does it mean? What do you think it means? That's all I want you to do. It's not really hard. Here comes the sun. Do, 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 do. All right, as you read along through the text, you're going to underline, which we can't. Makes me angry, but however, we will move on. It says we're supposed to underline and highlight, but we can't because, look, we can't do it. I'm sad. All right, what do we know about the sun? Since early in human history, people have marveled at the sun, which is true. That's another topic for a whole nother class, for a whole nother school, not middle school. However, we're going to move on. Civilization had referred to the sun by different names. Gods and goddesses who represented the sun were worshipped in different cultures. In addition, early astronomical words are hard today. Too much coffee. Observations were established to track the sun's motion across the sky. By the mid-19th century, astronomers had discovered that the sun was actually a hot ball of gas, comprised mostly of elements of hydrogen and helium. Scientists now know that the sun was born, his birthday was 4.6 billion years ago. Every second, 4 million tons of solar matter is converted into energy. Of the light emitted from the sun, 41% is visible light. Another 9% is ultraviolet light, and 50% is infrared radiation. Ooh, poisons. Ooh, that's no cool. And perhaps most important of all, without the sun, there would be no life on Earth, which is true. Y'all know that. We need the sun. All right, so here it is, sun statistics. So I like this little thing here. I might have to actually take a snippet of this and save that in a file for later for you guys and make a printable for this and make that go into your interactive notebooks on Teams. I might just boop, boop, pop. So you guys might one day wake up and see that this is there, because I think this is important information. Average distance from the sun, average distance from Earth is 149 million 0.6 kilometers. Again, you don't use miles. Yeah, I know that makes you guys completely cuckoo for Cocoa Puffs, but y'all are just gonna have to deal with the appropriate math. Oh, look, math. Here we go. It says number 6, calculate. You try it all on your own. Don't go to the interwebs, because I will know if you've gone to the interwebs. To determine a diameter of Earth is 12,756 kilometers. How many times greater is the sun's diameter? So how big is the sun compared to the Earth? And I know if you've already hit up Google, I know which one of you has already Googled this. Just do the math. I mean, if you look how big the sun is, which it tells you right here, and you subtract that number there, and have your answer using the calculator tool that is found right there. All right, I'm not going to do that for you. Hey, look, here's a little fact for us. A solar flare, which is shown in this image. Hello, solar flare. Ooh, very, very gross looking. Solar flares are not cute. That's kind of gross. This image is a sudden explosive release of energy in the sun's atmosphere. That's a solar flare. I don't know why it reminds me of something really gross, but it really does. Like lasagna getting stuck in water. That's what that looks like. All right. What is the structure of the sun? The composition of the sun and the Earth are different. However, and the two bodies are similar in structure. Both are spheres, which means they're round balls, and both have layers in the atmosphere and an interior composed of layers. The interior is composed of layers, which means, the Earth has the crust and the core and all that good stuff. Yeah, see? I told y'all, some of y'all called me a liar. Y'all just think it's a big floating gas bubble in the sky. I told you there was a core to it. It said right there in the book, in the middle of our sun is a core. Ha 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 ha. However, our sun will never be able to be a planet. It's too big. This is where energy is produced. From the core, energy is transported to the sun's surface through the radioactive zones. Oh no, radioactive, zombies, help us. Into the conductive zones. The sun's atmosphere has 1, 2, 3 layers. The photosphere, the chromosphere, and the corona. No. Do not even, I can hear y'all, and I don't even have to be near you, but I can already hear, no, moving along, do not do it. The sun's surface is the photosphere. Energy escapes from this layer The chromosphere is in the middle layer of the sun's atmosphere. The temperature of the chromosphere rises with the distance of the photosphere. And the sun's outer atmosphere is the corona. The corona extends millions of kilometers into space. So big. All right, number 7 right here. Here's number 7. Why is this structure of the sun different from the structure on Earth? Summarize your evidence. So why is this different than Earth? Why is the sun different than Earth? That's all I want to know. Oh, look, it looks like a sandwich. Yum, delicious. Looks like a little egg sandwich. So this is the corona. This here is the chromosphere. This here is the photosphere, the conductivity zone, the radioactive zone, and here's the core. Is really bright. You need some sunglasses, bro. Like, oh, goodness, could you imagine? So you guys can pause here. You guys can read all of those. I need you. Whoops. Forgot this little guy. So you need to read 1, 2, 3, 4, 5. You need to know all 5 of those on this page right here for me. This is on page 145 if you have your textbook. All right, next page. Here we go. Let's go together. Oh, this guy is very regal face. Very handsome fellow. Yes, nuclear fusion. Let's figure this out. How does the sun produce energy? Well, it's a big ball of gas. Gases. Is that a word? Gases? I think we're going to make a new word just for our class. Gases. Because he has gases. All right, cool. All right, so in the early 20th century, physicists, there's so many physicists. Albert Einstein. Is this him? I don't think so. I think so. Yes, young Albert. Look at him, so regal. Proposed that matter and energy are interchangeable. Matter can be changed into energy according to his famous equation, E equals mc squared. And people have been trying to figure out E is energy, M is matter, mass, and C is the conductive speed of light. People are so confused by that still. I don't know why in year 2020 people are still confused by that simple little thing, but I'm going to digress off my little soapbox. Because C is such a large number, tiny amounts of matter can produce huge amounts of energy. Using Einstein's formula, scientists were able to explain the huge quantities of energy. And you guys get stuck on quality and quantity. I don't know why. Huge parts of energy were produced by the sun, by nuclear fusion. Woo, so exciting. I wish we could do this during like Halloween time because we could go spooky with it. Anyway, scientists know that the sun generates energy through the process of nuclear fusion. Dun, dun, dun. What is nuclear fusion? Nuclear fusion is the process by which 2 or more low-mass atomic nuclei fuse to form another, heavier nucleus. Ugh, that's a lot of words. You're going to need to know all those words. So I need you to, like, this whole little part. That whole little part from nuclear fusion to that period right there, you're gonna have to know. You have to know it, okay? Highlight it. Do what you can. I can't highlight. I don't like highlighting. It's driving me crazy. All right. So nuclear fusion takes place in the core of the star. So the star, sun, soul, he's over there like constantly doing nuclear fusion. Like this guy is like a mad crazy scientist. He's a chemist. He's a freaking mathematician. He's doing all this work by himself up there in space. He's a loner. That's what happens when you're lonely. He needs friends. So I guess that's why he's trying to pull friends into him. But then he realizes he's a big monster and he likes to eat things like ram nom nom. Because what would happen if planets start getting sucked into our star? Nom nom nom, like Godzilla. Okay, and in the stars that have core temperatures similar to the sun, the fusion process that fuels the star starts with the fusion of 2 hydrogen nuclei. I know I said that wrong. Go ahead. I'll wait. Laugh. It's nuclei. In older stars in which core temperatures are hotter, the sun's fusion process involves the fusion of helium into carbon. They take helium and they shove it inside carbon. We don't do that in our sun. Our sun says no. All right, so number 8, thinking outside of our textbook. So claims, evidence, and reasonings. You know how much I love these. These better look fabulous too. I mean it. Like you better have this written on full paper. Einstein's equation, E equals mc squared, is probably the most famous equation in the world. Make a claim about what kinds of technology rely on this information, this matter. Summarizing your evidence to support your claim. Right here is a whole bunch of evidence. You can go outside the textbook. You can go, oh wait, let's see. I find other information here. Oh, let's go back over here. Pop him up, and you pop into this little thing over here. Oh, look. Well, let's not use that. That's a weird little Google. Oh, we like him. Excuse me, that's not what I wanted to do. My computer's being weird. I don't want to do that. I want to do this. Oh, Google. What is nuclear energy? Oh, that's very fun. But we don't want to learn about nuclear energy right now. What is nuclear? Not fission. Ooh, nuclear medicine? No thanks. What is it? And then we're going to type in this word. According. A crocodile? No, not a crocodile, Mrs. Henderson. According to NASA. Because we like to do everything with NASA. Because if we're going to do it, we're going to do it right. We're going to do it by the people who go into space all the time. We don't go there. Alright? So you can go in here and check it out and go to NASA. And you go to those NASA sites that I told you to save. There's two of them that I had you save. The original NASA site and the Space Place kid-friendly NASA zone, and that's where you can go find out more about nuclear fusion and play a whole bunch of video games and win some prizes through NASA. They'll give you little badges. It's super cute. This is what nuclear fusion looks like. So you have this little guy, these little guys, and you go pow, 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 pow. So you have the proton and the neutron, and they're all smashing together, and they just fuse, and it's super, super cool. So there's 1, 2, 3 steps according to our wonderful little dude up here. Look, I'm so regal. I love this photo of him. I want to get this photo. And she's like, I'm going to tell my great-grandchildren, this was your great-granddaddy. And they're going to be so confused because they won't know. They won't even look it up, I guarantee you. Okay, so by the fusion of hydrogen into helium. All right, so number 10, as always, is highlight and underline and color and mark it and make it pretty, but we can't because we're on this weird document site and I can't do it. And it won't let me. And I'm sad. It's okay, though. The most common elements in the sun are hydrogen and helium. It says the most common. So there's more than just one or two gases up there. There's several, but the most common are those two. Under the crushing force of the gravity, these gases are compressed and heated into the sun's core, where the temperatures reach, oh my good gosh, 15 million Celsius. In the sun's core, hydrogen nuclei sometimes fuses to form helium nucleus. This takes place in 3 steps to complete. This 3-step process is illustrated below. Oop, we're not going to sneak peek yet. Most of the time, when the protons are on a collision course with other protons, their positive charges instantly repel them. The protons cannot collide, but sometimes one proton will encounter another proton, and then that exact moment turn into a neutron and eject into an electron. This collision forms a nucleus that contains 1 proton and 1 neutron. This nucleus is an isotope of hydrogen and a word I can't pronounce, dirimetrine. Yeah, sure. This nucleus collides with another proton and forms a variety of helium called helium-3. And then step 2, then 2 helium-3 nuclei collide with and form helium-4 nucleuses. Oh, good lord. That has 2 protons and 2 neutrons. The remaining 2 protons are released back into the sun's core. The entire chain of fusion requires 6 hydrogen nuclei, and the rest has 1 helium nucleus and 2 hydrogen nuclei. There are approximately a very large number, because if you were to take 10 to the power of 38, it's a big number. It would fill up half this page, between hydrogen nuclei taking place in the sun's core every second, which keeps the sun shining. So if y'all want to be like the random students that I know you are, and you want to take 10 to the power of 3 and then push the equal button on your calculator, you'll see it was going to tell you error because it's too many and your poor calculator now has a headache and wants to take a bubble bath. Okay? Let's see what it looks like. Nuclear fusion. Da, 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 da. So I'm pretty sure there's a really cool like Magic School Bus or Bill Nye the Science Guy or somebody that has something about nuclear fusion. Whee! So this is step 1. They're bing bonging off each other. Step 2. They're sticking to each other like glue. Step 3. They're bing bonging, sticking, and bouncing all at the same time. It's a crazy hot mess up there. Look, gamma rays. Y'all are like, what are gamma rays? How do we know what they... Oh, look, there's one now. Ha ha ha. She made an appearance. Hey, Gamma, what's up, girl? How you been? Mixing it up. How is energy transferred to the sun's surface? Energy is transferred to the sun's surface by 2 different processes. Energy that is transferred from the sun's core through the radioactive zones. Uh-oh, radioactive once again. Da, da, da. I think that's how the Hulk was made. Or Spider-Man. Some superhero was made with something to do with radioactiveness. I don't remember which one. I don't keep up with that stuff. What was it to do with Barbie dolls? I don't know. I think maybe it was the Hulk. Or the Spider Dude. One of the two. I don't remember. Anyways, they were transferred by the process of radiation. Which there's a thing called radiation poisoning. And you'll get into that in 10th grade science. So... So, energy that has transferred from the top of the radioactive zone through the conductive zone, through the photosphere, is transferred by the process of convection. Not like your convection oven, but similar to your convection oven, if that makes sense. Because your convection oven just dumps a whole bunch of heat into one contained space and cooks your food. So yeah. Very similar to it, but in a different, it's a similar process, but in a different space. Energy flow from the sun's core outward to the sun's surface by radiation, and convection happens continuously. That is really hot. Just like leave your oven on for days. Don't do that, honestly. It's going to get really hot in your house. Even with the door shut, you're going to be, ugh, it's gross. It's just like living in Florida in the middle of August, okay? Think about that. Or Australia. I've never been to Australia, but I heard it's a pretty hot place. Okay, by radiation. When energy levels, when energy leaves the sun's core, it moves through the radioactive zone. I do believe that's it right here. So the radioactive zone, from the electromagnetic waves, the process by which energy is transferred as electromagnetic waves is called radiation. We just said radiation like 9 times. I think this is going to be one of those challenges. Like, yes, like on Friday, I had a student challenge me to say a word as many times as possible in one paragraph. And boy, was he shocked when I said yesterday. It was the word yesterday. And I said the word yesterday like so many times in one paragraph. He just sort of stared at me. Don't challenge me to say one word and then multiple. See, look, there it again. The radioactive zone is densely packed with particles such as hydrogen and helium and free electrons. Therefore, electromagnetic waves cannot travel directly through the radioactive zone. Instead, they are repeatedly absorbed and re-emitted by particles until they reach the top. So they have to do like this. Ooh, oh, I know. Think of a lava lamp. That's a good indication. By convection we shall stand. Yay! Energy that reaches the top of the radioactive zone is transferred into the sun's surface. In the conductive zone, energy is transferred by movement of matter. Hot gases rise to the surface of the sun and cool and then sink back into it. Yay! Just thought he was going somewhere. He's just like, nah, I just want to come out to see everybody. So what's up now? I'm going back home now. Bye. And they're converted back into the process in which heat is transferred by circulation or movement of matter is called convection. Convection takes place in convective cells. Convection, oh Lord, the convection cell is illustrated on the page on the opposite page. Convection cells Is this it? That's a convection cell. Ooh, look how pretty. It's so circly. Yeah, sometimes when things happen in circular motions, it means it's a circle. Okay, it's not a flat earth, it's not a pancake, it's a circle. All right, it's a ball. Goes like a ball. Think about a ball rolling around put a ball in a glass jar, like a little marble or a bead in a glass jar, and shake it around. What's gonna happen? It's moving around in a circle. All right. So, where did we go? It's called convection. Convection takes place in a convection cell. A convection cell is illustrated on the opposite page. Convection cells form granules on the surface. Why did they make the word granules look so important? Anywho, on the sun's surface, hot rising gases cause bright spots to form in the center of these granules. Cold sinking gases cause dark areas to form along the edges of the granules. Once the energy reaches to the photosphere, it escapes as visible light. Other forms of radiation, heat, and wind. Energy is transformed from the sun's core through the radioactive and conductive zones. Here they are now. Yay! It's so bright in the middle. Don't stare too hard. Boop-a-doo-doo. All right, what are these little things? Ooh, it looks like corn. Hey, yummy. Corn on the cob. How delicious. Tops of convection cells from granules on the sun's earth. It looks like corn. How do y'all not see this? Am I just like weird, or am I just like, I want corn now? Huh. Anyway, number 11. How is energy transformed from the sun's core to the sun's surface and the radioactive zone? Oh, yes, a zombie zone. Into the conductive zone. Betty Crocker zone versus zombie zone. Yummy. This is going to be interesting. So this is a T-chart. I'll need to do a little T-chart inside your book since you guys are at home and you can't do these practices with me. I'm so sorry, you guys. You guys are going to miss out on all the fun things on the sun because you're home and you're sick and I'm sad and I miss you. Hot rising gases from the cold sinking gas form conductive cells in the conductive zone. How many times can I say the word conductive? Dum, dum, dum. So how many days it takes? It takes 35, 31, 28. Oh, 28 days. That's a movie. Ooh, that's a scary movie. 28 days later. I think it's a zombie movie or the end of the world. I don't know. I watched too many movies. I can't keep them up. What kind of line is this? I wonder what this red line is. Look at the sun. Sun just looks like, when you break it down like this one, it looks like corn. But then it just looks like, yeah, it still looks like corn. Yep, it does. How does the sun rotate? Oh, that's a good question. Does the sun rotate or does it sort of like sit there stagnant? Huh. Wait, there's this thing called gravitational pull though. So it has to be spinning on some kind of axis. I know the Earth's axes are at a tilt. They're at an angle. Because if we were up and down, we'd spin really fast like a top. And our brains would be splattered ill. So we're sort of like tilted axis. We sort of rotate, kind of like laying back, chilling. Yeah, we spin really fast, but probably not as fast as the sun. The sun rotates on an axis like all other large bodies. Oh, okay, cool. It does. Look at that. In the solar system, however, because the sun is a giant ball of gas, it does not rotate the same way as solid bodies like Earth. Well, that's obvious. Instead, the sun rotates faster as its equator. Oh, that's what the red line is. It's the equator of the sun. It's so cool. Awesome. Instead, it rotates faster than the equator than it does in the higher latitudes. This kind of rotation is known as differential rotation. Differential rotation, for some reason, is italicized, so therefore I would normally tell you to highlight this whole section. However, we can't highlight on this piece of paper. A differential rotation is the rotation of a body in which different parts of a body have different periods of rotation. Bleh. Near the equator of the sun, the sun rotates about 25 days. However, at the poles of the sun, there's the South Pole. At the poles of the sun rotates once about every 35 days. Confusion? What? I'm confusion. Okay, great. Even stranger is the fact that the sun's interior does not rotate in the same way the sun's surface does. What is going on with the sun has lost his mind. He's going all crazy in there. The scientists think the sun's core is and the radioactive zone rotate together at the same speed. Therefore, the sun's radioactive zone and core rotate like Earth. That's a lot to take in. In your own words, define the word differential rotation. So, again, in your own words, not googlemail.com. Okay? Great. We are almost there. We are almost completely finished with this. Ring of fire! Ooh, what is your solar activity? Solar activity refers to variations in appearance or energy output of the sun. Solar activity includes dark areas that occur on the sun's surface, known as sunspots. Solar activities also include sudden explosive events on the sun's surface, not the Earth's surface. This is the sun, which are called solar flares. We finally get to solar flares. You mentioned it up there, but now, okay, cool, great. Another form of solar activity is primaries. Someone please, for 2 extra points on your paper, if you'll tell me how to pronounce this, that would be great. Are vast loops of gas that extend into the sun's outer atmosphere. Sunspots. Ew, is it like the gross little... Oh, it's like the gross little spots that are on my hand. Ew, gross. Cancerous. Blech. Dark areas. Yep, there it is. That form on the surface of your skin, I mean the sun, are called sunspots. Ew. I told you things in space relate back to things on Earth. You get sunspots on your skin and the sun gets spots on his skin. Told you. There are about 1,500 Celsius cooler than the areas that are surrounding them. So I wouldn't suggest walking on it, but it's cooler than this area over here. Sunspots are places where hot conductive gases are prevented from reaching the sun's surface. Sunspots can appear for periods of a few hours to a few months. Some spots are only a few hundred kilometers across. Others have widths that are between 10 to 15 times the diameter of Earth. So basically, Earth can fall into one of these little black holes on the sun. Lovely. That's always lovely and fun to know. Just plop. Inside goes Earth. I told you, this little guy likes to eat. He's hungry. He's coming after us. He's going to eat Mars first, though. Sunspot activities occur on average 11-year cycle. When the cycle begins, the number of sunspots is at a minimum. The number of sunspots and then increase until it reaches a maximum. The number begins to decrease. A new sunspot cycle begins when the sunspot number reaches the minimum again. Why did you just say that in like one sentence? I could have said that in one sentence. Why do you have to use all the next words? Alright, cool. Sunspot activity from the 1600s to 2000. Wow, they have been tracking the sun forever. Like I said, that's a whole nother topic for a whole nother class in a whole nother school. You do the math. So support your claim. I want you guys to do this little number 13 right here. We are almost done, I promise. So sunspots range is the difference between the maximum number of sunspots and the minimum number of sunspots of a certain period of time. To find this range, subtract the minimum number of sunspots from the maximum number of sunspots. What is the range of sunspots activity between 1700 and 1800? Summarize your evidence. So you gotta do some math again. So one little line. You go ba-doop-a-doop, doop-a-doop-a-doop, and then boop, 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 right. Okay? I can't mark on this paper. It makes me crazy. Oh, solar flare. Oh, hey, he's got hair. Yeah, look, he's got some little cat in a hat and cringe hair going on there. That's so cute. He's got bedhead. He just woke up. So, solar flares. So this one here I don't need to read to you because we just read the same exact things up in the pages above. So this here is, of course, your beautiful Venn diagram. You are going to tell me what solar flares are. Do not give me, I do not want the book definition that is located here. I want you to tell me, in other words, do you understand? Great, I'm glad. So, what is a solar flare? What is this? What do they have in common? Yep. Last page. So you're just going to finish up number 15 and number 16. 17, you don't need to do those pages. You can just do number 17, all right? Because this is the model of the sun, and it's going to be so much fun. So all I need you to do is complete this, fill this out, and turn it in to me. I am trying to figure out where my camera is. There you are. Where'd I go? Ha! There you are. All right, guys. So I had so much fun today reading to you guys, reading with you about solar flares and all the fun things to do with space. We know already that this is one of my favorite topics to talk about with you guys because you guys just get so excited when it comes to new things, but not excited when it comes to learning about dirt. I'm confusion. Anyways, guys, thank you for joining me in class again today. I will see you next week, hopefully. Bye.